I got some interesting results on assignment number 6. Some I was pleased with and some I wasn't so pleased with. So maybe I got grumpy and grouchy and I decided to not let you do any correcting because the drawing was so simple.
You're just mean.
I know,
It's simple.
that's okay. If you would like to discuss it with me, I'm open to discussion.
Yeah, there's no discussion. You're just mean.
Have you corrected all of assignment 6?
Yes, electronically.
Okay.
Find it on the D2L.
Right.
Because all I asked for was an electronic copy of it.
Yeah.
Which,
So if
thank
you
by
didn't
the
get
way.
something back from assignment 6, go look in D2L if you submitted it. All right, the next assignment is assignment number 7. And if we go back to the course calendar, we are in week number 6. So 6, 7, 8, 9. That's like 4 weeks worth of work, and then 10 is getting everything done. Most of you are doing pretty well at staying up. Some of you are not doing so well at staying up, which brings me back to what I discussed last week, that in week number 7, I'm seriously considering revising this particular assignment here, or possibly not doing it at all.
All for the latter.
Which means for those of you that are up to date, you'll get a little bit of breathing space. For those of you that aren't up to date, you'll get a little chance to get some things in and corrected and red lines finished, and so we don't have a big huge crush at the end. I may or may not move this assignment up. I may just leave it where it is, and just modify this particular assignment here. So we skipped assignment number 5. We may skip assignment number 8. And I hope you don't mind.
No.
And all of you in video land, I hope you don't mind. So far the consensus seems to be that's okay. All right. So assignment number 7, it should be relatively easy. He says, hopefully. And let me pull that up. So I downloaded the assignment 7 3D solid model gear instructions. Pull that over here. Which is using your program of choice. Either AutoCAD, 3D solid modeling, SolidWorks, or Inventor. And I believe all of you have had at least the AutoCAD 3D solid modeling class. I think if you create it in AutoCAD 3D solid modeling, you can import it into Inventor, I believe. At least that's the way it's been in the past.
Why would we want to do that?
Huh?
Why would we want to do that? Just draw it in.
Well, we'll figure it out, if that's how you do it. I would suggest either SolidWorks or Inventor to start with. And then you're going to create a 3D solid model of a spur gear. And when your 3D solid model is complete, you need to save an STL file. It's a slice file. I know it's called STL in SolidWorks. I think it's a little bit different nomenclature in Inventor. It's
No, it's the same.
Is it same?
Yeah.
STL? Okay. Right. And then take that STL file and upload it into D2L in the assignment submission folder. And then save a copy for yourself, and when you're done, you're going to use that to make a 3D printed model of your gear. and you'll need the STL file, and then we'll need to convert it into the MakerBot software and print it out on the MakerBots. When you get around to printing, on Monday and on Wednesday, there is a class that is in this room starting at 6 o'clock. Justin has his CAD 105 digital design class, and then I think it's Phil has an inventor class in here. No, there is no class on Wednesday. I think it's only on Monday. You cannot start your 3D printed file of your gear. You have to check how much time it's going to take, which you can do in MakerBot in the software. If you're going to start it at 4 and it's going to take 3 hours to run,
Ain't gonna work.
you're not going to start it, or it's going to get paused in the middle of it so that it doesn't interrupt. Well, you can't start it because they need all the printers on Monday for the 3D class.
So that would mean like coming in on a Saturday lab.
Or you can print it on Wednesday. You could print it on Tuesday night during advanced class if you've got me for the instructor.
Or I can run it up to you.
Or you can, if it doesn't work out timing wise, you can send me the STL file and I can print it out for you. But it'd be a good opportunity to practice with it as well. All right, here is the design information for the gear that I want you to create. Diametral pitch is 8, pitch diameter is 3, number of teeth is 24, outside diameter is 3 1/4 inch, face width 3/16. I don't want them really huge because it's going to take enough time as it is. Bore diameter is 7/8 of an inch. Keyway size is 3/16. It needs to be able to accept a 3/16 inch square key. Now think about that. If it's a 3/16 inch key, it's going to be 3/16 of an inch wide, but it's only going to be 3/32 of an inch high in your gear. The other half of that 3/16, the 3/32, ends up in a shaft. Now I'm hopeful to get my little checking fixtures fixed. Last year, the precision of the MakerBots wasn't what I had when I first created a little checking device, and nothing ever fit, because I'd like a shaft to be able to fit into your gear and a keyway to fit as well. And then it's supposed to kind of mesh up with another gear that has the same number of teeth and diametral pitch, but I'm going to have to kind of do some adjustments on my end of it to see if I can get it. That was part of the requirement, is that it had to be able to fit the shaft, had to be able to fit the key, had to be able to mesh up with another gear. So I've got to see if I can modify my check device and see it actually operate. All right, so you're using the approximate involute curve to do the drafting. You will need to calculate so that you can construct the 3D model: a base circle, a circular pitch, addendum, dedendum, and clearance. You're going to use the calculation chart on page 24 or 763, and I'm going to go over the construction of the tooth profile. Once your 3D solid model of the gear is complete, then you can make the 3D print of it on the printers. Any questions so far? Okay, then let's move forward. Now there are instructions on how to draw a spur gear step by step. There is listed instructions. Construct an arc or circle representing the base circle. That's why you have to calculate that. Construct an arc or circle representing the pitch diameter. Construct center lines. From the intersection of the vertical center line and the pitch diameter, draw a horizontal line. Construct a 20-degree line from the intersection of the vertical center line and the pitch diameter. Construct a line from the center of the circle perpendicular to the 20-degree line. using the endpoint of the line that was just constructed as the center of a circle, draw a circle whose radius is pitch diameter divided by 8 equals 0.375. Trim the circle to an arc, divide the circumference of the pitch diameter by 360. This gives you the distance each degree is along the circumference, which should end up being 0.026. The width of the tooth is the circular pitch, CP divided by 2. CP is equal to 3.1416 divided by 8 equals 0.3927, which is then divided by 2 is equal to 0.196. That gives you the amount of distance along the circumference. Making sense so far? Sure. Divide the tooth width by 0.06. 0.196 divided by 0.206 equals 7.54. This is the degrees on the circumference between point T and S on the handout. Construct a line from the center of the circle to the intersection of the arc and the pitch diameter. Rotate that line 7.54 degrees, or create another line at an angle of 7.54 degrees between the lines. Construct a line between the endpoint of the rotated line and the intersection of the arc and the PD. Construct a line perpendicular to the line just constructed as the line's midpoint. Mirror the arc. Construct an arc or circle that is offset, the addendum, from the pitch diameter. Construct an arc or circle that is offset, the addendum, from the pitch diameter. Construct an arc or a circle that is offset, the clearance from the addendum, 0.02. Extend the arcs to the dedendum. Fill out the arc and the clearance with a radius of 0.035. Trim the upper part of the tooth profile. Array the tooth construction, extrude, boom, you got it.
Sounds like an afternoon of fun.
Simple enough? It
You
wouldn't be if this is all you had, okay? That's very complicated written instructions. Because we're drafters and we like visual things, not just instructions, there are visuals associated with this project as well, which are PDFs. If you have the written instructions in front of you and the visual creation, you should be able to create, oh, that didn't get, okay. This is an error. I was trying to get a new PDF up in there and it should have updated, but this should be 3.25.
3 1/4.
And evidently I haven't gotten that finished yet, so before you actually download this one off
Mine
of
says
D2L,
3.25.
His
is it
system.
3.25?
Have you refreshed?
I haven't refreshed. Oh, well, that could be why.
I heard that from you once.
Did I?
Yeah, you told me that once.
Maybe. Let's see what happens. No, it still didn't do it, so I'm not sure what happened here. Alright. So if you have the written instructions, step number 1 says to construct an arc or a circle representing the base circle. I would suggest a circle. So in the written instruction, you've got what you're supposed to do. In the visual instructions, step 1, base circle, pitch diameter times the cosine of something. And I actually give you what the numbers are. 3 times the cosine of 10, it looks like, equals 2.82. You should be able to draw all of this with the instructions, step-by-step instructions relating to each step. Step number 2 is a pitch diameter. Written instructions say, construct an arc or circle representing the pitch diameter. Step 3, construct center lines. So you need center lines. And then it goes by step, this little angle thing in here. So step 3. Step 4, step 5, 6, 7, 8. 9, 10, and 11 are calculated. There's a step 12, 13, 14, 15, and 16, which goes along with the verbal or the written instruction sheet. Between the two of them, you should be able to get this accomplished. There's page 1, there's page 2, and there's page 3 as PDFs. So we're up to step 16 on this one. Should be 17 on the next page. So step 17, 18, and 19, that goes along with your instructions. Construct an arc or circle that is offset the addendum from the pitch diameter. Construct an arc or circle that is offset the dedendum from the pitch diameter. Construct an arc or circle that is offset the clearance from the dedendum. And then you go in and you fillet this little corner in here and this little corner in here per the written instructions. And then page 3 shows you that on the PDFs as well. So step 20, 21, and 22. So you're you have to have enough clearance so that the top edge of the gears don't bottom out on the matching set of gears. That's the idea for the clearance. Now, I'm pretty sure that there's probably not going to be any questions now, but there will be as you get into it. What has happened in the past is that when people actually follow the step-by-step written instructions and visual instructions, it generally isn't too complicated. It's when you get off track or kind of skip a step or something like that is what happens when you have problems that come out. Or maybe you don't do the array pattern quite right.
Did you show the first illustration again?
Can we print
This one?
this?
Yeah, so the 3 inches diameter is supposed to be 3.
This is 3.25.
Okay, so is that what the pitch diameter should be on this as well?
No. That's,
Okay.
I think that's part of the calculation.
Well, it looks like both arrows are pointing to the same circle. The pitch diameter, step 2. That's what's confusing me.
Yeah, I think they're different.
Okay, because
Step
it
21.
says the pitch is 3.
The outside diameter is supposed to be 3 1/4.
Okay. Okay, got it.
Okay.
Yeah.
If you get a copy that has 3 on it, change that to 3.25. Like I said, I was pretty sure I got that changed
Okay.
over, but if you downloaded it before I actually changed it over.
Now mine says 3.25.
Okay. Then it should be okay.
All right.
That's it.
Yeah.
Sam?
Is there a specific reason why it has to be, you can't do it from the center of the, like why it has to be tilted?
Those are the instructions of how to draw a spur gear.
Okay.
I didn't make up the instructions, I just followed them. And how to construct it. Like I say, if you follow the instructions, you should be okay. If not,
I just wondered why you couldn't draw it. from
probably
the
could,
center.
but anyway, those are what I have.
Okay.
Okay. That was probably the shortest lecture you'll get in kinematics.